So this is a physics question based on gravitation that came in the JEE Mains April 2024 attempt. April 2024 attempt. Assuming Earth to be a sphere of uniform mass density, a body weighed 300 Newton on its surface. How much would it weigh at r/4 depth under the surface? The most straightforward way to do this would be to apply the direct formula for gravitation acceleration or force, which is this acceleration times the mass of the body under a certain depth. But here we can derive it to understand how it actually works. 300 is for g/mm by r square, where r is just the r is the radius because the object is at the surface. It's at a distance r from the center of the earth. Now we are looking at weight at r4 depth under the surface, r/4 depth, which means it's actually 3r/4 distance from the center of the earth. So what we get for that is, since it assumes Earth to be a sphere of uniform mass density, we have to write mass in terms of density and volume, because since the radius is going to be changing under the surface, the volume is going to be changing, but the density is uniform. So what we do is we write 300 is equal to g small m by r square into rho, which is constant, into the volume of the earth, which is 4/3 pi r cube. So for our new calculations, we are going to find for at 3r/4 distance from the center of the earth, which is going to be gm by 3r/4 the whole square into rho 4/3 pi 3r/4 the whole cube. So we square the terms and we get the 4 squared 16 goes to the numerator. We get 16 gm by 9r square. The thing is, we're going to get this answer in terms of the first answer, and therefore you can find how much of the 300 it is and calculate it. So what we get is 16 gm by 9r square into rho 4/3 pi. We get 3r cube to be 27 r cube divided by 64, this whole thing. So 64 goes to the denominator. So we are going to group these terms, 16 into 27 into the constant terms, which are going to be, this is small m, this is small m. So yeah, the constant terms gm rho 4/3 pi divided by r square being constant term here too, divided by 9 into 64. So this right here is actually, this right here, the r cube here too. So this right here is actually what 300 is. You can see gm by r square into rho 4/3 pi r cube. But the new one at 3r/4 distance from the center is going to be 16 into 27 divided by 9 into 64 of that. So we take it out. We get 3 here. We get 4 here. So we get 3/4 times this whole term, which turns out to be 300. So we get 3/4 into 300. 4 cancels out. We get 75. We get it to be 225 newtons. So it's going to be 3/4 the force that is on the surface at 3/4 the distance from the center.